This video covers section 2.3 from your notes. It's titled Problem Solving Applications of Linear Equations, and in it we are going to be looking at how to solve linear equations. We're going to start out though by kind of reviewing a problem solving process, just some steps that are a good idea to go through as you try to tackle any application problem, which we know can be a little difficult, so it's good to kind of remember some simple steps. Then we're going to look at some formulas which might be helpful, and then we're going to do some examples to help get you ready to do your homework. So first thing is, it's always a good idea to read the problem, but not only read it twice, maybe one just to kind of once through to get a general idea of what's going on, but then when you read it a second time, you're trying to pull important information out of the problem. Then as you read it, write down that important information. Write it down. Write down what you know. Maybe draw a picture if necessary. And then, since we're going to be able to want to solve for something, you're going to need to define some variables. You got to know what it is that you're solving for. After that, you're going to want to try to write an equation which relates the variables and the information into some sort of equation that you can solve. And then step 5, of course, solve that equation. And then lastly, write your answer down in a complete sentence. So if we take a look at some of those important formulas that we might want to use, let's go ahead and look at those. The first formula is for the rectangular shape. Rectangles have dimensions of length and width, and we could talk about the perimeter. The perimeter is when you add up all the sides in the rectangle. So there's actually two sides of length, of two widths, and there's two lengths. And so your equation here is going to be for, we'll call P, capital P for perimeter. You're going to have two W's, W plus W, which makes 2W. And then also two L's, because you have L plus L. So when you add up all four sides, you get that the perimeter is 2W plus 2L. We also have, you can find the area of a rectangle. The area is the space here that's inside the rectangle. And to find that, we multiply the length times the width. So we take the length and we multiply it times the width. So those are your two important formulas for rectangles. And squares are pretty similar, except we have all four sides are the same. So if we have this side is S, and this side's S, and this side's S, they're all S. So if you want to talk about the perimeter, this was area up here. If you want to talk about the perimeter, in this case, the perimeter is equal to S plus S plus S plus S, which we know is 4S. And then the area, we multiply just like before, length times width to get the area inside. But in this case, it's not length times width, it's S times S, which we know is S squared, side squared. Now for a triangle, we can think about it as having a height H, and then it has a base down here B, which is this whole distance along the bottom. And if we wanted to find the area of that triangle, the area would be 1/2 times the base times the height. Or sometimes people write it like this: base times height divided by 2. Either one of those formulas are the same thing. Okay, we can also talk about the area of a circle, and the area of the circle relates to the distance, or it uses the distance from the center of the circle out to the side. You remember what that's called? That's called the radius, R. That's the radius. And so the area of a circle can be found by taking a number, pi, times the radius squared. It's another formula. So Also with a circle, we can talk about the circumference of a circle. We'll use capital C, and that is 2 times pi times the radius r. This is the circumference of the circle, and this is the circumference is the distance around a circle, around the outside. Okay, so that's kind of for some different geometry shapes. We also have the formula distance equals rate times time. With angles, we can talk about complementary angles. Those are angles that add up to 90 degrees. And we can also talk about supplementary angles. Those are angles that add up to 180 degrees. And then for any triangle, like the one we have up here, this triangle, the three angles, and the angles are these parts. That's an angle, that's an angle, that's an angle. Those three angles have to add up to how many degrees? They add up to 180 degrees. Alright, now sometimes when we do these type of application problems, we need to be able to describe one quantity in terms of another. So it might give us a sentence where it says, for example, the length of a rectangle is 5 less than twice the width. And we kind of talked about this before. Remember when it says 5 less than? That means that we are subtracting 5. Subtract 5 from our quantity. So in this case, we're going to subtract 5 from the width. So it will be, or sorry, it's not the width, but twice the width. So we'll subtract 5 from twice the width. So we'll take twice the width and we'll subtract 5 from it. If we describe the length, then we're describing the length in terms of the width, because the length is 5 less than twice the width. We're just going to let the width stay w. So we can do the same thing here in this next one. Think about, can you do this one on your own? It says one angle is 10 more than 3 times another angle. So one angle, say A, is 10 more than, not 5 less than, but 10 more than 3 times another angle. And we'll let that other angle be B. So we'll just let B be B, and then we'll let this angle be 10 more than 3 times that other angle. Okay, I think we're at the place where we can try some examples now. So here we go. Let's read through the problem. It says 14 less than 5 times a number is 121. This is one where we can just go ahead and jump right into writing the equation, because it's basically telling us the equation in English. And there's some key words here. One of the key words is that remember this less than. Less than means subtract. And 5 times, remember what times means? That's multiplication. A number, what's a number? The number, that's the variable that we're solving for. And then is, you know what is? Is equals. So let's write that equation. It says 14 less than 5 times a number. And remember, we have to, when we say 14 less than, we're subtracting 14, but we're doing it on the end. So we have to write it like this. 5x minus 14. So 14 less than 5 times a number, and then is equals 121. And the one thing we did forget to do is to define our variable if we go through our steps. So that x, let's let x equals the unknown number. You get in a good habit of writing down what the variable is that we want to solve for. Alright, so now we just solve. We want to know what that number is. We got to solve for x, which means we got to get the x's on one side, numbers on the other. So we're going to move this to the other side. When I move it, I know I change sides, change signs, so that becomes a positive 14. Okay, so this is going to be 5x is all that's left on the left side. The right side is 135. When I divide 135 by 5, what do we get? We get 27. So x is equal to 27. So we could write a sentence here. The number is 27. There we go. Example 1 done. Example 2. It says the length of a rectangle is 7 less than twice its width. If the perimeter of the rectangle is 64 inches, find the dimensions of the rectangle. Alright, so let's read through again and start to write down some things that we know. It says the length of a rectangle. So let's call L the length, and let's call W the width. This tells us something about the length. It tells us a little equation here. It says that the length of the rectangle is, what is again? Is equal. So the length is 7 less than. Remember, whenever we see less than, that means we got to subtract. So we're never going to subtract 7, but subtract 7 from what? Well, it's 7 less than twice the width. So we have twice the width minus 7. That is equal to the length. So the length is 7 less than twice the width. Now, it says if the perimeter is 64 inches, so this is telling us P. It says P is 64 inches. It says find the dimensions of the rectangle. So when I say dimensions, dimensions mean what is W equal to and what is the length equal to. I think the last thing we can do here is draw a picture. We know that we have a length and a length and a width and a width, and if we want to find the perimeter, or if we're using the perimeter means we add all those up. So remember, if you look back on the previous page, the width, or the perimeter is 2 times the width plus 2 times the length. So let's write this down again. So the perimeter is 2 lengths plus 2 widths. But we know the perimeter. The perimeter was given to us as 64. So we can put 64 in there. And now there's 2 variables here, and we need to be able to get this down to 1 variable. So this is where we're going to use this other bit of information here, because we know that the length is 2W minus 7. So I can take and replace that, or in math we call that substituting. I can take this L and I can replace it with something, and let's put that something in parentheses, because what L is equal to this 2W minus 7. So when I go ahead and put that in there, I can replace L with 2W minus 7 and then add 2W on the end of that. That's this 2W over here. And now we have an equation to solve. We just solve this and we have our answer. So we have, do what we can do first. Let's get rid of the parentheses. 2 times 2W is 4W. And then also take 2 times negative 7 is negative 14. We still have the 2W on the end. Combine like terms. So we have 64 equals 4W and 2W added together makes 6W minus 14. We only have W's on the right hand side, so let's leave that there, and then let's move this negative 14 to the other side. When we change sides, we change signs, so that negative 14 becomes a positive 14. So 64 plus 14, that's 78 equals 6W. Let's bring this up over here. 78 is equal to 6W. And we would need to solve for W. We got to divide both sides by 6. So divide by 6, divide by 6. and that tells us what W, or the width, is. The width then is going to be 13. And remember, we need to find the dimension, so we need to find the width and the length. But we know the length is 2 times W, or 2 times 13 minus 7. And 2 times 13 is 26. And we subtract 7 from that, we get 19. So the length is 19. So we have the length is 19, what kind of units here? 19 inches. And the width, we already found, was 13 inches. Those are the dimensions of our rectangle. We have a few more examples here. It says the sum of 3 consecutive odd integers is 237. Now, do we know what odd integers are? Odd numbers are numbers like, for example, 1, 3, 5, 7, 9, etc. Right? And how far apart are odd numbers? To get from 1 to 3, this is a distance apart here of 2, and then to get from 3 to 5, it's another 2, and to get from 5 to 7, it's another 2. So odd numbers are always 2 apart. Yes? Odd numbers are 2 units apart from each other. So, and I want to find the sum. Do you remember what sum means? Sum means to add. So if I want to add 3 consecutive odd integers, I want to add something plus something plus something. I want to find their sum and have them add up to 237. Now the problem is we don't know what either of those 3 numbers are. If we let the first number be x, though, and we know the next number is 2 more than that, can I just say that the next odd number is going to be 2 more than the first one? And then the third one is going to be 2 more than that one. So if I add another 2 onto this, so I have x plus 2 plus another 2, that one's going to be x plus 4, because, go back to this example over here, 5 is how much more than 1? 5 is 4 more than 1. So we can say that the third number is 4 more than the first one. So this is my equation that we need to solve, and we can combine like terms because we have 1, 2, 3 x's, and then we have 2 plus 4 makes 6, and that should add up to 237. And let's go ahead and move that 6 to the other side. It becomes a negative 6, and if I take and subtract 6 from 237, I get 231. We're doing all right. And then we can go ahead and divide that 3 out. And if I do that, I get that x is equal to 77. And so my numbers, that has to be the first number, so my next odd number is 79, and my next odd number has to be what? 81. That's my answer there. And for the sake of time, I'm not going to write this as a complete sentence, but you would write something like 3 consecutive odd integers are 77, 79, and 81. Okay? Next example. Angles A and B are complementary angles. Now, go back up in your notes. What did we learn about complementary angles? Complementary angles add up to what? Okay, so let's go ahead and look at our next one here. It says A and B are complementary angles. What does complementary angles mean? Look back on the first page of your notes. That means they add up to how much? They add up to 90 degrees. Complementary angles add up to 90 degrees. So it says A and B are complementary angles. So that means A plus B, they add up to 90. We're almost there, except we have this problem of having two variables again. So let's see what other information we know. It says if the measure of A is, oh, it looks like we got another equation here, because this says A equals 30 more than. That means I got to add 30 to something. What am I adding 30 to? 30 more than the measure of B. So A is 30 more than B. So I can take what that A is equal to and I can plug it in for A over here in the equation. And so that equation now looks like instead of A on the front here, it's going to be B plus 30. We still bring that second B down because we didn't plug anything in there, and that's equal to 90. Then do what we can do, combine like terms, B plus B, that makes 2B. We add that to 30, and we get 90. Move that 30 to the other side. It becomes a negative 30. Change sides, change signs. And we get 2B is equal to 60, and if we divide by 2, we get B is equal to 30 degrees, and if those two angles have to add up to 90, and we know that A is 30 more than B, then that means A has got to be 60 degrees. Of course, you can take that by taking B and adding 30. Right? 30 plus 30 is 60. So my answer is that A is 60 degrees and B is 30 degrees. We got one more example. It says AJ drove his car at a rate of 125 miles per hour for 4 hours. How far did he drive? Well, we know that distance is equal to rate times time. And we know that the rate, that's how fast he was driving. He was driving 125 miles per hour. And we know the time because it says he drove for 4 hours. So my distance is my rate times my time of 4 hours. And what's that? What's 125 times 4? That's 500, and the units are going to be miles. Alright, so now we finished that video. Go ahead and do your self-check, and we'll see you in class. Thank you.